The main difference is that DevOps is mainly about concepts and methodologies and best practices like continuous integration, continuous deployment, short iterations. And there's one special concept, which is you build it, you run it, which is mainly possible in the cloud. The thing is that when you do so many things, if you don't have help, if you don't have the right tools, the cognitive load, right? So the mental load you have to have in memory all these things that you need to know about and do well. If you don't have something that helps you, it just doesn't work, right? That's why platform engineering tries to keep or manage this complexity so teams can deliver value to the business.
Okay, so it's a lot about combining product mindset with software and system engineering expertise.
Platform engineering is based on leverage, right? So this means that a few engineers can make the other engineers much more productive or much more effective by switching their role from just doing product to doing this platform.
Hi, I'm Maria Chec, and this is the Agile State of Mind. Welcome. Today I'm joined once again by João Alves. Hi, João.
Hello, Maria.
Nice to see you. We could speak in so many languages, right? My Portuñol is like another language already.
It's very good.
Thank you. João is back for the second appearance on the podcast. The first time we spoke, we dove deeply into the engineering manager role. And right now, you switched your role from engineering manager to head of engineering, where you manage engineering managers, right?
Indeed.
And you still work in Adevinta.
I still work for Adevinta, 5 years now.
Okay, so that's an interesting also evolution. This time we're shifting to a topic that's very hot in tech right now, platform engineering. And I actually have this book here.
Wow.
And I have actually two books about platform engineering. I would like to jump right into it, because last time actually when we worked together, all the hype was on DevOps. It was in like 2017 or 18, and we were working in Free Now. And I remember you were like this ambassador of DevOps. DevOps is a culture. It's not just an engineer. And now suddenly, like, what has changed that we are talking about platform engineering? Is DevOps dead? Is it passé? Is it like, do they coexist? Tell me.
Very good. Thank you, Maria, and thank you for having me. In short, right, back in the days of Free Now, I actually proposed the creation of a platform engineering team, right? And so to me, the main difference is that DevOps is mainly about concepts and methodologies and best practices like continuous integration, continuous deployment, short iterations. And there's one special concept, which is you build it, you run it, which is mainly possible in the cloud, meaning that the teams, they are owners of running the whole software show, not just building it and then throwing it away to a systems team to operate it, but they are in charge of operating it in production, etc. Right?
Yeah. So it's like we minimize the handovers.
Exactly.
Okay. So, but that gave the teams even more load, right? And even more things to know that they have to deal with. And I imagine they weren't too happy.
Exactly, right. The thing is that when you do so many things, if you don't have help, if you don't have the right tools, the cognitive load, right? So the mental load you have to have in memory all these things that you need to know about and do well. If you don't have something that helps you, it just doesn't work, right? That's why platform engineering tries to keep or manage this complexity so teams can deliver value to the business.
Okay, so it's a lot about combining product mindset with software and system engineering expertise. But to me, that sounds like it is for big corporations that have loads and lots of teams and big and complex code bases. So can you explain a bit, who is it for? Do you have to be like a big corporation to be platform engineering? Because you mentioned we could do it in Free Now. So
the thing is that platform engineering is based on leverage, right? So this means that a few engineers can make the other engineers much more productive or much more effective by switching their role from just doing product to doing these platforms, right? The thing is that even a small company, imagine a company that operates websites for
Mhm.
other companies, right? Uh, there's one fundamental question to these engineering teams. How do we put a website in production that has an HTTPS, which is fairly standard these days, and has all the security guardrails and all the things I need by default, right? And there's many ways of doing this. Even in the cloud provider, there's many ways of doing this. The role of a
Mm.
platform is to choose one golden path, one paved road to do this. I want to put a website in production. Okay, here is your way to do it, right? So I think the difference between big corporations and small companies is how much of an effort you put in platform engineering. Mainly for a team of 50 engineers, maybe you put 1-2 people in charge of this. For a team of 1,000 engineers, maybe you put 50, 100 people, right? So roughly 5 to 10% of your organization.
Okay, so you can still do it. It just depends how many. So you can still do it. It doesn't mean you cannot. It's just we will have maybe 1-2 people, and in the other one you will have like you will probably restructure the whole company. So you have a platform teams and the application teams, or is that how it works?
Yeah, usually is how it works. And the former CTO of Twitter, he wrote a very good blog post on the matter, right? Let 1,000 flowers bloom, and he explains a bit the math behind how to structure this platform versus product teams. But because at the end of the day, you don't want to put too many people on the platform side because you still want to deliver product, but you need to put like the right amount so you are more effective as an overall engineering organization.
Okay, and you mentioned some key concepts for me. When I read about platform engineering, I read about scalability, reliability, and security. So, does it mean all of this should be in that platform?
So ideally, the platform should have everything baked in, right? The reality is a bit more messy because first, there's limited time, even for platform teams, what they can do, what the features they can ship. Everything is limited in this life, right? But in short, so what platform teams should do is curate a bit these needs, right? So what are the primary needs from the business? Are they driven by reliability or by compliance or by security or whatever, and then prioritize what to bake in this golden path, right? So you have this
Mhm.
by default, and teams don't need to think about this, right? So we reduce the cognitive load once again, but at the end of the day, platform engineering teams, if they are well run as a product, right, they also need to make these trade-offs. In a product, you cannot implement everything.
Okay. Okay. So I understand that we remove the cognitive load from the teams, that they don't have to worry about some complex new technologies. Some of those things go away, some of the things they need still to do. And how do we do that? And I read a lot about how trust is important in those teams and how this product mindset is important. So, because there is always this fear that they will just want to run there is this new super cool technology and let's do it, and then they start creating platforms that nobody wants to use because they are so cool and super modern and innovative, but they don't respond to what the teams actually struggle with, right? So you have to run some kind of surveys and know, how do you know what the teams need, so you can create abstractions and extrapolate that work and create this leverage that you mentioned.
Yeah. So I think the primary thing platform teams need to understand is that they are there to make other teams more effective, but ultimately to serve the business, right? So I
Mm-hmm.
wrote this somehow when I was running a platform team, and this was the main purpose of the team, right? And this means that you don't do technology for the sake of technology. You run surveys, but you also go and speak to your colleagues in the product side. Okay, what are your needs? What are you struggling with? Because sometimes people, they don't express their needs, like any customer in the world, they don't express their needs precisely. So what are your struggles? Measuring also how good are teams, like with the Dora Metrics, are they delivering on time? Are they delivering a lot of software value? And if not, start digging why, and then you can realize what are the root causes of this problem, and in some cases solve this pain. And when you see the instance of this pain once, thrice, then you can extrapolate it and create it as a problem.
Okay. There are a few things here. So you mentioned Dora Metrics. Dora Metrics and SLOs are the two things I hear constantly when it comes to like measuring and making sure it stays within the guardrails. So could you explain those two concepts?
Yeah. So Dora Metrics, they came from a book called Accelerate, and basically they studied a lot of software development teams and realized what make teams high performance, right? In terms of software delivery, not in like as a unit. And there are some things like the lead time to deployment, the mean time to failure rate, these kind of things, right? There are 4 metrics that they condense this how good you are as a software development team, right? So is one thing.
Mm-hmm.
And then SLOs are a completely different thing, right? So as a team, imagine that you provide a chat system and you want to understand how good you are providing this chat system. And for that, you need to choose few metrics. Okay, I'm good delivering my chat system if all my messages are delivered in less than 1 second, right? You choose one indicator, and then you choose an objective to reach. I want to deliver 99% of all the message in my platform in less than 1 second, right? So first you choose an indicator, an SLI, service level indicator, and then you put an objective on top of it, so you know how good you are delivering your software. Then, of course, you need to act if something goes below this threshold, and this is a way for teams to understand how good they are, right? So then this is what the difference is.
Dora Metrics would be more looking at the efficiency, effectiveness, high performance.
Yeah.
And the other one is more concerned with actual value that we provide to the customers. But when you say 99% of the time, it means also that it's very high, right? The threshold.
I mean, yeah, it depends on your business, right? Some businesses, they require higher objectives. Some businesses, they require less, right? So it's a conversation that tech teams or product and tech teams, they can just set these numbers randomly, and they need to understand the business where they are operating in. For instance, at FreeNow, if you cannot order a taxi at 8 p.m. on a Friday or 9 p.m. on a Friday, there's a huge loss of revenue, right? So reliability is super important, especially at peak time. In other categories of software, maybe 1 minute of downtime at 8 p.m. is okay, right? So these kind of things, they already make you realize that it's a conversation that you need to have with business, and actually putting just 99 or 99.9 or whatever you want to do is as a cost, right? So people, they need to understand the trade-off between, okay, we want to be that good versus we need to pay for that.
Okay. I guess this could also indicate where we need to put our money and what we need to work on, because we are not getting to this reliability that we need. But still, it feels like, oh, this is the tech roadmap. It's not really the product roadmap, right? We are not giving a new value. We are just making sure the value is provided that we already have. So how do you typically create initiatives or features that span out of this SLOs that we are breaking? How does that work? How your tech roadmap is built?
Again, right? So if for your business something is important, right? So again, 1 minute of downtime or a data breach or something, then of course this needs the respective prioritization. If you are constantly breaking your SLO and no action can be prioritized there, it's because your SLO most likely is not realistic. Maybe your business doesn't care as much as you thought of, right? And this is also something you realize. If you ask what are the critical flows in any software company, people will tell you 20 things. And then when things start breaking and you start having conversations with you, realize, okay, maybe there are 2 things that are really, really important, and the other 18, they are somewhat important, but less, right? It's again a matter of prioritizing it correctly. And here is where I think platform engineering can help a lot as well, right? So because reliability and these topics that they are so hard to get right, if you have a platform where you get observability and monitoring by default, where you can set your SLOs, where because of the way your platform is orchestrated, you are deploying your services into cloud regions. So if one cloud region is down, you keep serving your customers. These kind of things, they help cut down the cost of having a super reliable system, for instance.
Mm-hmm. Okay, so this is also important for me because it's not like, again, it's agile state of mind. We are agile. We have to have iterations and feedback loops because you can start with a lot of SLOs and very ambitious ones. And then you start seeing, okay, those nobody cares about. Those, they don't really show that we are not reliable because it's a peak of some peaks at night and nobody uses our service at night, right?
Exactly.
So we have to keep this something alive and keep on reviewing them. How do you typically do that? How do you review the SLOs? Do you have a sync with all the leaders?
Previously, what we did in my team was every month we were checking the SLOs and checking the level of compliance and taking actions based on that, right? So if it's something that we are consuming part of our error budget, let's see if we need to do something. And in some cases, we even adjust it because it's basically it was too high, the SLO, and it was not that important, right? So it was always an ongoing conversation with stakeholders, and even if you ask, is it very important for you? People will say yes, but then you need to again check this regularly and see, okay, this was super important, but is broken for 1 month and no one complained, so maybe we can just relax it.
Yeah, exactly. I think that's the key thing here as well, that nothing is written in stone. And also we have to check because sometimes we have the other way around, right? We have perception that something is wrong, but the SLOs show everything in green and Dora Metrics are green and everything seems like we are running great. And then you have this kind of bias, like, what's going on? Why we have a perception and we feel something is not going great, but we don't see it reflected on our metrics.
Yeah. This happens all the time, right? So sometimes it's hard to capture what is the impact we are having on the customer, right? And that should be our ultimate goal, right? So the ultimate goal is that we don't create this dissonance between what we are measuring and all is green versus what the customer is experiencing, right? So that's why SLOs are not just a product and tech tool; it's a tool to align business and product and tech, and this should reflect what the user is experiencing, right? So if the database is at 100% CPU load, does that matter if the user keeps doing their stuff and the system is acting correctly, right? So these kind of things is, I think, what is important to keep in mind.
Okay, that's an interesting one. So talking about SLOs, I cannot not talk about SREs now. So because you mentioned reliability, for me, SRE, the site reliability engineering and engineers, what is that? How does it have anything to do with the SLOs?
Kinda. So site reliability engineer is a concept that was born at Google, and the idea is that these folks are software experts and they automate operations, right? So they are engineers first, but they are not operators, because the usual difference is that, yeah, I'm an operator of the software. I restart it. I look at metrics, but SREs are on the side of automating this, right? So, and they build tools to monitor, deploy for instant response, right? So they ensure that system meets these defined SLOs that we discussed before, and they of course are focused on reducing toil, right? This manual work, this repetitive work that you do as an engineering team, like, okay, every now and then I need to clean my disk on my instance in Amazon because it's getting full, right? So these things, they should be automated. And then the model you use, there are several models of SREs. There are models where the SRE is embedded in the team, right? So it's collocated with the product team, so they define together how to manage their operations, especially in the beginning of projects or products. This happen a lot. There are SREs that are shared amongst teams because mature product and tech teams, they already have their SLOs, they already have a way to monitoring these systems, and sometimes they need specific help from these folks. And then there are teams that are more centralized, like more like consulting ways, right? So this team of SREs can act as a consultant or bootstrapper for new services until they are made.
Okay, so that's, I guess, the perfect world. And now let's talk about the reality, because from what I saw, we consider them as kind of the incident responders. Sometimes they have to put out all the fires. For me, SRE is like platform engineering foundation, and it's great to see your face now. But then that they are the ones responsible for creating the SLOs and making sure we have those covered and alarms whenever necessary.
It depends on your model, right? So in some models, the site reliability engineer, they are responsible that the system meets these SLOs, right? And this has some good parts and some bad parts. And the bad parts are mainly that the product and tech teams that they are operating the service or in charge of this service, they may detach themselves from this, and they, right? So this is one thing. But in general, are they just firemen? Ideally, no. The reality, though, is that, like you said, so these folks usually are very seasoned, very experimented, and they know how to deal with incidents. They know how to debug things, complex distributed systems, and so on and so forth. And it's true that sometimes they are pulled into an investigation, into an incident. But in my view, the ideal world would be that these folks, they do trainings with product and tech teams. Okay, you know how to do an incident response. You know how what kind of severity this implies for the business and when to call in for help. When the incident is mitigated, you know how to run a proper postmortem. You ask the 5 whys, you go to the root cause of the things, you publish a postmortem, and you take actions based on this. This would be my ideal scenario for SREs and how I've been working in Adavinta so far. Right, so teams are very mature in that sense, but I agree that in the beginning and in some companies, it's just how it works. Right, so firemen.
Yeah. When it comes to incident response, who's responsible? Because if you have DevOps teams, you typically you run it, you made it, now you run it. So now you should be the one that's on call, right?
Yeah.
When something goes wrong. But if you have SREs and they are so specialized, shouldn't they be the ones that actually can bring back the service or do some rollback quickly or whatever is needed when there is some downtime? So I would like to understand, if you have SRE, does it mean DevOps is dead there? Like there's no DevOps, or you have both? You have like on call, the SRE is on call, but there's also teams on call. Who's on call?
The scale is full of grays, right? but in short, right? So if we are applying DevOps correctly, and if the teams have the right platforms and the right building blocks and tools, they should be able to bring their service back, right? There's also the reality, and the reality is that sometimes an incident just spawns outside of the scope of that team, right? So imagine that you are a team in charge of the chat, the messaging system of your company, and somewhere there's a problem in the Kubernetes that the platform team takes care of, right? So in these cases, there's a need, one, for coordination, right? So the incident response needs to have some coordination, and two, debugging may be more complex because maybe there are 2, 3, 4, 5 systems at stake, and until you drill down onto the root cause, you need someone that can help you deep dive into these systems altogether, right? To have a more holistic view. So I would not say that if you have SREs, you don't do DevOps, right? So ideally, teams should be self-contained within their scope, but sometimes things just span out.
So you say that we should ideally have teams that operate like you build it, you run it, you're a DevOps operation, but then you also have as a team your SLOs and you take a look at them, but then you have this support from platform engineering. But then isn't that like too many things? Like, isn't the idea that if you already have platform engineering, the teams have less to be,
Yeah,
to care
the
about?
idea is the people they have the right abstractions, right,
Mm-hmm.
to operate this, but it does not mean that you are relieved from all of it, right? So a practical example, you have the user database. It's a huge database, right? And this
Mm-hmm.
database needs indexes and needs things that they are coupled to the domain, and they require expertise on the domain of user, right? So if you want to offload that to the platform team, right, then you create some perverse incentives here where one, the team that needs to have this domain knowledge, they offload it to somewhere else. And now the platform team, they need to get this domain knowledge, and maybe they spend time there that they could spend in some other cases where they could make, for instance, alerting on a table that needs an index that will make you perform, and that will help the team that is taking care of the user database be more performant, right? So it's all about trade-offs. I don't think there's a silver bullet for.
Okay, but could you explain a bit? So we decide to go and have platform engineering mindset or the platform teams. What would be the typical services or areas that they would typically do? Like almost every company would have them do like CI/CD or like pipelines to develop, right?
Yeah, so I would say CI/CD for sure. Runtime like Kubernetes, this kind and hardcore infrastructure that is not provided as a full service from the cloud providers, right? So you can, of course, spin up a Kubernetes in AWS or a Google Cloud Platform, but you still need to operate it, right? Because the model is that they offer you infrastructure as a service, so you are still responsible for lots of things. So I would say that the hardcore parts, yes, but in short, what I would say is that platform engineering should be more about use cases than specific capabilities, than CI/CD. And so use cases mean I want to deploy a static website somewhere, and I want to have an SSL certificate for that. I want to deploy a microservice that is replicated into regions, and I want a database that automatically scales, right? So these are the things versus things like I need an S3 bucket, or I need a CI pipeline, or I need a Terraform, right? So use cases, product mindset versus the details.
Okay, that's nice. I like it. So you write a user story for that, and then from there it makes sense because then you focus more on the outcomes and not on the way to get there, because it might be different ways in different companies.
And you focus on the user persona, right? Because maybe machine learning engineers, they need some stuff to deploy their models and to train their models, and backend engineers need another thing, and mobile engineers need another thing, right?
Yes. And here, talking about this, could you explain what abstraction is? So abstract.
An abstraction is just that you use something without fully knowing the details, right? So the example I always like to give is that at your home, you have electricity, you just turn on and the light comes in, right? But
it's magic.
It's
I always
magic.
thought it's magic.
But you don't need to know how the energy is generated, how it's transported to your home. You don't need to know any of this. You just know that it works, right? So there's an abstraction to this, that then this is you have a contract and you pay by your usage. So an abstraction is this, using something without knowing the full details of it.
Okay, so there are those people in platform engineering who know how to deal with it, and I so fully have to trust them that they know, and I can just switch on my brand new service and it just automatically spans.
Exactly, right? You know that you want a securized service and replicate it into regions, right? But you don't necessarily know how to do this, right? So that's the difference.
Cool. Okay. And last but not least, my last thing that I would like you to clarify today, and I will share the screen to show what you sent me before we spoke, because it's about this stuff as a service, IaaS, PaaS, and SaaS, and all those things. And so, can you explain this?
Well, so this is focused on IaaS, I think we can just go on IaaS, PaaS, and SaaS, right? So
Yes. Mm-hmm.
The thing is that when you go to the cloud, right? So the networking, storage, service, and virtualization, they are taken care of by Amazon Web Services, Google, blah blah blah. You then
Mm-hmm.
have many ways of providing this. One way is to provide an infrastructure as a service, meaning that you get a virtual machine and you can do everything with it, but you are also responsible for, okay, how do I run my software on top of this
Mm-hmm.
virtual machine? I'm responsible for upgrading the operating system, so Linux, and then making sure it's patched,
Mm-hmm.
making sure it's up to date, blah blah. I need to make sure that I store the data securely, and I need, of course, to make sure that my application runs correctly, right? So you are owner of a lot of things, yeah.
But this can be just so in my
Mhm.
head. One thing can be that I use AWS and they
Yes.
provide it as an IaaS or
Mhm.
PaaS, right? But there can be also like inside of my company, the
Okay.
platform teams can provide me as product team one or the other, right? It's also possible.
It's also possible, right? So
Exactly.
if you provide a way for people to spin up virtual machines, you are providing
Mm-hmm.
an IaaS, right? If you are
Uh-huh.
providing like something like Kubernetes as a service for your company, you are more on the PaaS
Mm-hmm.
side of things, right? And if you are providing like a chat system that other teams can use for their own use cases, like support chat and then chat peer-to-peer chat in your product and these kind of things, you are providing more like a SaaS, even
So
internally, right?
for Adevinta, let's take it as an example. You have a website to buy
Yeah.
cars, for
Yeah.
example, right? So it's like a marketplace, and you have people who want to chat, so you need a chat inside of there. So you even in Adevinta, you can provide SaaS to other teams, so they just plug it in and they use
Yeah.
chat as okay.
Yeah, because you have this chat that you mean, but you can also have a chat between customer service and professional services, right? So it's
So
not the
something
only
like
chat.
a help desk or Zendesk is a SaaS that we use, or Slack, right?
Exactly. Slack is a SaaS, yes.
Mm-hmm. Okay, and you can even internally in the company provide. So this is like this explains how platform teams interact with the rest of the teams. This what we see here, and we can even say like, hey, so we as a platform team will create this chat for you, and you will operate it as a SaaS. Is that
No, we create the
how
SaaS and
you?
we operate it for you, and you just use the API. You don't need to care about data. You don't need to care about running the application. You just call an API and you get an answer, right?
Okay. All right. Cool. Makes sense. So for me, I think the biggest thing here was like, I don't understand. Is it AWS that provides it for me, or is it inside the team that provides it for other people? So that's can be both.
The difference is
And
more on what is the shared responsibility model, right? So what one team is responsible for and what the other team is responsible for. In SaaS, the consumer is responsible for zero thing, right?
mhm.
And in IaaS, the consumer of this IaaS is responsible for many things.
Okay. So it's about how much you have to do based on
Exactly.
what you are receiving. And okay, and is there any advantage of having IaaS? Is there any advantage? Like, would I ever want to do that if I can have it done by others?
It depends, right? So
Okay.
so
Okay.
if your team is very specialized and they need to control the operating system, etc., of course, IaaS is a good solution. If your team is not specialized and they just want to do an API call to a service and get it done, most likely not, right? So
Okay. So it depends also on like strategy and structure
and
that we
costs,
have.
right? So developing a SaaS is much more costly than developing an IaaS. These kind of things is also something you need
Hmm.
to take in mind.
Okay. Yeah, makes sense. And then you have to operate everything. So it's also about like how much of the third party you want to use in what you do.
Yeah.
Okay. Cool. Wow, that was a lot. So could you maybe like summarize it and see how you see this in the future now that we have also AI coming? Do you see that platform engineering is a way to go?
I think platforms are more important than ever, right? So independently of who creates or operates it, if it's an agent or if it's AI or creating and operating
Mm-hmm.
this platform, it's more important than ever because as you create much more code, as you create much more software, if you don't do platforms right, you will suffer bottlenecks because it will create so many things that you want to deploy and you want to put in production that this is a required building block, to be honest.
Okay, so no escaping platforms.
Hopefully.
I'm going to the platform con next week, and that's why I wanted really to have this conversation. And you said, do you have any like recommendations for books? We can also, you have also your articles, so I can also put them in the show notes for everyone to read a bit more. They are very, you are like a storyteller, so though just a heads up for people, like it won't be technical stuff, it will be actually a story from João that he will explain you a little bit about it.
At the end, this always needs to be connected to these use cases and to the business, and if you don't tell the story, people won't really buy it, right?
And then examples, like I really like that you gave this example of the chat. Everybody understands a chat, maybe not everyone understands like S3 buckets and Kubernetes stuff, but chat we understand Slack, and we understand how that works. So this really helps. So I will add at least those 2 articles that you sent to me. And anything else, anyone that you would
the book
say?
you just mentioned from Camille Fournier about platform engineering, but also her blog posts about it. Also Charity Majors, she used to be a production engineering at Facebook, and now she runs their own Honeycomb, the observability company. And Gregor Hope, he has a book called Platform Strategy. It deep dives into different kinds of platforms and what is a good platform and what not. And I think it's a really good book. I think so. Yeah, I don't have the physical one. Yes, this one.
Yeah. Okay. So the sea life, there is the salamandra here. Yeah. Why, I have no clue. And then I also have different topologies, which I imagine about the cognitive load and how you want to understand why those structures are important, right?
Indeed, although team topologies is broader than platform strategy or the platform engineering per se.
Yeah, exactly. It's also about like organizing, structuring your business and what works in which use case. Okay, great. Thank you so much for taking time and bearing with my questions and the one-on-one questions. I think this will be very interesting because it's for people like I am that we maybe not hands-on engineers, but people that want to understand where they are and how those different pieces come together, and really, really helps. So thanks so much.
Thank you, Maria. I hope it's helpful for your audience.
Bye-bye.
Bye-bye.